All right, so we're going to continue on with volumes with cross sections. The difference here is today we're going to have 3 different types of shapes. Okay, one being a equilateral triangle. Now the nice thing is I've been told that you do not have to memorize this one. Usually when you get this question, they give you the formula for it. Because here's the formula, it is the square root of 3 over 4 s squared dx, where s is f of x minus g of x. So again, I've been told usually this is given to you. All right. Now, if you have an isosceles right triangle, if you think about what an isosceles right triangle is, it's half a square. So it's half side squared. Where s is still f of x minus g of x. Now, it is the circle that, or the semicircle that gets a bit tricky. Okay. So, because you do know the area of a semicircle, right? What's the area of a semicircle? Pi r squared. All right. But here's the issue. Okay. The diameter is f of x minus g of x. And what is the radius? Half of that. So 1/2 of f of x minus g of x. Actually, and I should, yeah. So if you plug this in, all right, we are going to get, we're going to simplify this. So you plug this in, we get 1/2 of pi times 1/2 of f of x minus g of x squared. All right, we're going to square that 1/2, right? This is going to give you what? 1/4. Integral from a to b. So if I can bring that out, I can actually write this as 1/8 pi integral from a to b of f of x minus g of x squared. Now, do you have to know this right here? No, but it will make it easier. All right, you really just need to know this, and just know that when they give you f of x and g of x, what they're giving you is the radius as the base of the semicircle. So they're giving you the diameter of the semicircle, not the radius. So we're going to take that same information we had yesterday, where we had y is equal to the square root of x and y is equal to x squared as my 2 functions. Right? And we're going to just set, we're not going to solve, we're just going to set up the integrals. Okay? So the first one, equilateral triangle, it is from, they intersect at 0 and 1, because again, this is based upon what we did last class. So they intersected at 0 and 1. And the formula is square root of 3 over 4 of the square root of x minus x squared dx. Now you can bring this outside, root 3 over 4, 0 to 1, if you want. Just, if you remember, when you're given an equilateral triangle 60, 60, 60, where you have all these are the same S, 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 all right? How do you find area of a triangle? Based on type. Well, an equilateral triangle, do you remember 30, 60, 90-degree triangles? Yeah. So this right here is 1/2 of S. And that would be 1/2 of s times root 3. So you end up the height is root 3 over 2. The base is, times s. Base is s, so the area is 1/2 of root 3 over 2 times s times s. So you end up with root 3 over 4 s squared. That's where that comes from. Easy, right?
Sure.
Been doing
I also taught this later, earlier this year to my geometry class. So yeah.
Yes.
Yes. Area of the equilateral triangle. But quickly. Yeah.
But I think you're teaching integrals.
No, I'm not teaching them integrals yet. One day they will, some of them anyway. So, being that I have some 8th graders in geometry honors, yeah. Yeah. Most of you guys, juniors, probably took 8th grade geometry honors, right?
I didn't. I just took
Yeah. So, algebra 2, pre-cal. Yeah. All right. So, isosceles triangle, again, my side is equal to the square root of x minus x squared. So since we're doing the integral from 0 to 1 of 1/2 of square root of x minus x squared squared. Again, you can bring the 1/2 out if you want. Well, I am forgetting that, didn't I? Yeah, don't forget the dx. They will mark you off for that if you take the AP test.
That.
Yeah.
I was thinking.
All right, and then the circle. Now again, if you have this memorized, let's say if you memorize this right here, which again, it will take memorization if you want to have that, because you're not going to be given that. You can use the integral from a to b of 1/2 of pi r squared. You just need to know that r is 1/2 of the square root of x minus x squared. So plugging all that in, integral from 0 to 1 of 1/2 pi times that squared, so 1/4 of the square root of x minus x squared squared, which you can simplify that as 1 over 8, or pi over 8 if you want. 0 to 1, square root of x minus x squared squared. Dx. Don't forget the dx. So that's it for the notes. Let's do a few of these.
You guys are
So here we have semicircle cross section perpendicular to the x-axis, so we're going this direction. So in this case, my upper function would be just 2, and my lower function will be x to the 1/3, which is probably how I'm going to write it. All right. So again, it is much easier if you just remember that this is going to be pi over 8 integral. And it looks like they go from, if I plug in 8, I get 2, so it's going to go from 0 to 8. Of 2 minus x to the 1/3 squared dx. And the nice thing is, how do I solve this? Calculator. Don't do these by hand if you can help it. So integrate from 0 to 8. Oh, I did forget the pi rate, didn't I? Oh, I'll just do times pi rate out here. All right, so we have 2 minus x to the 1/3. Squared. So we get 1.2566. Any questions? Pretty easy, hopefully. All right. Number 2, equilateral triangle, sections perpendicular to the y-axis. Now, if it's perpendicular to the y-axis, what do we have to do? In terms of y. Now, if you turn your paper sideways, okay, you will see that this function right here is the only function you need to worry about. I don't need to worry about y equals 2 except for my what? My bounds. So I'm going to integrate from 0 to 2, but I don't need to worry about this function anymore because it's no longer, the y-axis is now my lower function. So, but I do need to change y equals x to the 1/3 into a function of y. So you're going to cube both sides, x equals y cubed. So it is just y cubed squared dy. Which in this case, we could just do the integral. Now, these are, what are these equilateral triangles, right? What am I forgetting? Equilateral triangle? Root 3 over 4. So if we do the integration, we have root 3 over 4 times the integral from 0 to 2 of y to the 6th dy. Root 3 over 4 times what? 1/7 y to the 7th from 0 to 2. Now, 0 would just give you 0, which is nice. So I really just got to plug in 2 here, and 2 to the 7th power is 128. Because 2 to the 5th power is 32. 32 times 4 is 128. You guys didn't grow up with megabytes, okay? You didn't grow up megabytes. And what that means is every time a computer expanded its memory, it doubles. It goes by, it's a binomial expansion. So it goes by twos. So it went from a 16-bit to a 32-bit to a 64-bit to 128-bit to it would double every time. So you have it memorized because, again, that's how our computers expanded in memory. Hey.
I'll take this test.
What?
I saw it from like all the way in there.
Okay. So anyway, yeah, it is 128 over 7. So we ended up now, you're actually going to reduce this by 4. So you end up with 32 root 3 over 7.
Uh-huh.
Now, if you put that in your calculator, what'd you get? Not 32 root 3 over 7. If you put the actual integration. So if you did 3 over 4 times the integral from 0 to 2 of just y to the 6 or x to the 6. Yeah, 7.91746. So yeah, you can do these by hand sometimes. Okay, I just didn't want to do number 1 by hand because I'd have to do what? Yeah, you'd have to multiply that out and then do the power rule. That's not fun. It wasn't easy as this one. Why don't you guys try number 3? Try number 3. You get a real nice answer for this one. Yes, you do. A nice whole number answer.
4.5.
It's not 4.5. It's a whole number answer.
Hey.
You got to remember that was the notes that I had from that other person.
Yeah, we never know at this point.
Yeah, it's true. But no, it's not 4.5.
Yes. No, it's when I was my neighbor. This is yes. I'm when it's like really here. Alright, it's just how it just there's this all why it's not Although, is this the thing? Yes, why would you just this is also and well, that's not that's the this this other bus station. What was it? And the one before this which one's not is not Black ACT. Oh, I haven't. This is uh yeah. Okay. It's not. And then they call us. This is a question. Is it more than three? These are pretty easy questions. English, I don't understand those. Those two. And then. Okay. It's already stuff in stuff. Okay. Yes. I think it's that. Did you get it? What? Boston. Boston Party HSC. Baby girls. You can watch it. See that with the. You said Boston. He does, he's out, so you said. Huh? Very.
What'd you guys get? One. Answer is one. So you are going to integrate this. Now this is an isosceles right triangle. So nice things that is 1/2 of the integral from 1 to 3 of just what? Square root of x minus 1 squared dx? All right. Which is just 1/2 the integral from 1 to 3 of x minus 1 dx. Gives you 1/2 of 1/2 x squared minus x from 1 to 3. So 1/2 of, plug in 3, we get what? 9/2 minus 3. Right? Let's do that. All right, plug in 1, we get a negative 1/2 plus 1. So 9 minus 1/2 is 8, which is 4.
It's positive.
Yeah, so we get,
Now you.
yeah, we get 2. 1/2 2 is 1. So yeah, that's it. Now the other one isn't as nice as this one. So in this case, when we do perpendicular to the y-axis, we will need to use the function x equals 3 because that would be our larger function. And we take y is equal to the square root of x minus 1, square both sides, y squared equals x minus 1, x equal to y squared plus 1. So we are going to do pi over 8 times the integral for the y. Oh, what are the y value here? Is it square root of 2? Okay. So from 0 square root of 2 of 3 minus y squared minus 1 squared dy. And I'm just going to plug in the calculator. Well, I'm not doing that one by hand.
I'll play with it again. Chill. I got that right. What would be so? Then you know, yeah. They go to the script. What's up?
3 minus 1 we can just write as 2. So 2 minus x squared squared. And we get 1.847. 1.1846. Well, 8 when you round correctly. Right.
1.1 is 4.
I think you guys are okay. Any questions on homework you think you are going to have questions on? Besides the last two? It will help to actually graph it out.
I need that.
I saw
I really like the last one, which should tell you something.
since you said it's horrible.
Yeah. So what shape is that? So if you have semicircles in a circle, what does that create? Hemisphere. So you could just find the volume of the hemisphere.
You remember.
Yeah.
It's
Just half the volume of the sphere. Volume of a sphere is what? 1/4 pi r cubed? Yeah, I know how to do those. All right. So I'll let you guys get started.